Okay, let us continue to the Birch reduction part 2. Now this part 2 is for benzene or like systems, how it is going to react. So let's revise once again what is the reagent in this reaction. We discussed in earlier slide that it is not possible for terminal alkyne, it is possible for internal alkyne. It is also possible for conjugated diene systems, and it is also possible for benzene like system, but I think these things are covered in the previous video. You can find out as Birch reduction. And now this is Birch reduction part 2, in which we are going to deal with what will happen to benzene in such reaction. So as you can see here, the first step is this E which you have drawn here. Can I say this electron can be brought here, this bond will break in favor of the other carbon, and because of this, what we can expect here, we can expect this ring system to take this kind of shape. I am drawing one radical here, and in this place I am putting one negative. So can we call this as anion? This part is anion, and this is radical which we have created here. Due to this, what will happen? Can I say the next step could be keep distance between these two things. Which two things? This one, okay, this radical, and this anion. If you observe this, we can't keep them so close, so we have to make sure that these two things are at appropriate distance, at an appropriate distance. So for that matter, we can take help of conjugation in benzene system, and we can say that, okay, fine, let us send this negative charge here. So in this process, can we expect the structure taking this form where radical is here, negative charge reaches at this place, and this is double bond position. After getting this, what is the next step? So we know very well, this negative has to grab hydrogen from where it can do so. It can take help of NH3, and as in the previous case also we have done the same thing. It will form same structure we can draw. We can put these two double bonds. We can put hydrogen. Now this is the hydrogen which is having source in NH3, which is taken along with Na. So can we say the other portion will still remain radical? What will happen to radical later? This radical will again get one more electron from sodium, and this electron will make it anion. If it is anion, we can get anion at this place, double bond at this place, hydrogen at this place. Later, this can grab hydrogen from ammonia, and finally it can give us answer which is double bonds which are not conjugated. Very important, this double bond is not conjugated. Now, can we say, is it necessary that double bond should be non-conjugated? What if by mistake I draw something like this? Let's say I draw a structure where I claim that, okay, fine, let's keep hydrogen here and here. Try to understand, this is a conjugated system. Can I say it will again react? So that possibility does not exist. So I hope you understood the process. So this is going to give you what kind of answer? This is going to give you an answer which is a non-conjugating, or we can say anything which is out of conjugation. So see, double, single, single, double, there is no conjugation here, and both the hydrogens have come on the opposite terminal. Now let us see extension to this reaction. We are given this time one CH3 which is electron pushing group, okay, and I can take one more example when NO2 is drawn, which is electron withdrawing group, okay. So what will be the future course of this reaction? Can I say in this situation, if you bring Na gives Na plus plus electron, and by mistake I attack on this position, so see what will happen. You are going to create radical at this place, and similarly, since you're creating radical at this place, you will create anion at this place. Now remember, radical at this place, anion at this place, this anion can move further here, but remember that radical is on CH3. So can I say the future course of this as a carbon ion will be highly unstable? So what is the correct way to draw this? Should I do this thing? No. it is suggestible that we attack it on some other position. Let us try this position. Okay, if this position we attack, can I say this bond will break towards this, and we can expect an answer which is CH3 at this place, and we have a radical here and negative charge at this place with these two double bonds. Now we can send this negative charge to diagonally opposite position for further stability, and the structure takes this shape. This is negative. Later, the same story will be repeated, that this goes, grabs hydrogen, releases NH2 minus, formation of a compound or intermediate mainly, which is CH3 double bond, hydrogen at this place and radical at this place. Later, Na will provide one more electron, which will ensure that this also becomes anion, and if this also becomes anion, then this hydrogen is here, CH3 is placed here. Later this will go and grab hydrogen from ammonia, and the final answer will be these two double bonds opposite to each other, hydrogen here, CH3 at this place and 1H at this place. Try to observe that the placement of these double bonds is in such a way that it is next to this CH3. Be very clear about it. Okay, so can we predict the answer for this case is going to be NO2 at here, and these two double bonds, hydrogen coming up here and here. Why will H come here? So we can explain this very easily, that this H is coming up here because creation of minus charge at this position of NO2 is highly preferred. Why it is preferred? Because NO2 is an electron withdrawing group. I hope you like this video. So kindly like, share and tell to your friends also regarding this. Thank you very much.